of the more recent, wanted to share something after one of the more recent fires that we experienced in the Palisades. This is an architect here, Michael Kovac, and this is a home he designed. And after the fire, what were some of the lessons learned that were implemented here? You can see it's a modern house on a hill, like many houses in the wildland urban interface. He did some things. His house did survive, and he's known for developing structures that will survive in these contexts. And there's some challenging features that he's dealing with. You can see overhangs and all of that, but he also has a vegetation palette that's very strong in terms of its resistance to that kind of insult from a wildfire. Next slide. So what were some of the lessons and some of the things that he has looked at? And some of the things you'll hear about today: defensible landscaping, creating that defensible space. It's a huge issue. And now in California, we're introducing here what's called the ember zone. So that's your first 5 feet within the building. He used gravel, volcanic rock, notice no mulch. He also planted succulents, which are well suited for areas around the house. He employed non-combustible siding. We have a lot of pressure, of course, to use wood, and it doesn't mean wood isn't used throughout the structure, but he made sure to seal wood elements where he expected an exposure hazard. Class A roof, I mean, that's kind of a no-brainer. But he also had portions that were planted green roofs. So it doesn't necessarily negate the possibility of interesting design. It just means that we have to think about how we protect the structure below such spaces and what we plant on those green roofs. Very importantly, in his case, high performance windows. We're driven often by energy codes to use these, but certainly from a wildfire perspective, we get great benefits. Next. Part and parcel with this approach, it's many of the things he did were not specifically for wildfires. It was also really driven by his desire to meet the LEED Platinum standard, and also to demonstrate, at the same time, he could demonstrate that he was recycling and using low impact construction, which I thought was really important. My message here is that we don't have to throw out all the things we've valued as designers over the years and the things that we think, set apart these professional designs. He embraced those and got basically a dual benefit from many of the things he was doing for other purposes, including that low impact construction. At the end of the day, passive design elements, were a big part of what defended his home. So the two need not be distinct from one another. In his case, he had insulated windows and a green roof. And again, he had water efficient landscaping, but this allowed him to control that vegetation and to protect the enclosure. And through all this, he was able to demonstrate what we all seek to do, I think, which is architectural innovation. Next. Key takeaways, to think about, that I had spoken about were layered defense. Things go wrong in the real world all the time. And in one concept of fire protection that I've always appreciated is we want the belt and the suspenders, because inevitably the belt breaks, the suspenders sag, it could be any of those. So we do many things. I was speaking with a friend, and he had this beautiful quote. He said, sometimes doing 99% or doing 100% of what you need to do is passing. And in the case of wildfire, doing 99% could be failing. So that's why we want to make sure we have as many things working for us as possible. I want to emphasize there are both combustible and non-combustible paths. Wood is an issue when you have a constant radiative exposure. We'll talk about that later. But again, it's about how you implement those features. How do you use wood in your design if you're going to use it? Are you using it as an attachment? Are you using it as a siding? You have to really think about things. And again, we'll get into that. We generally want to avoid attachments, of course. The big issue that very few people are talking about is maintenance. So once you've delivered this beautiful home, once you're in your home, what are the ongoing maintenance issues that drive this? It's probably one of the biggest factors in whether your structure will survive a wildfire event. Resources wise, I can't encourage people enough to look into IBHS. I think that IBHS, and obviously we have others who will speak to that, but they have some of the best experimental backed guidance. So my closing thought, is that the risk is not going away. That's not what the trends show. But I think that the smart designs, many of the lessons that many of you all have learned over the years are 100% applicable. We just have to pay attention to the very specific details along the way to make sure that we can design these homes and these structures as resilient against wildfire. Thank you.
Thank you, Nate. Let's hand it over to Evan.
Awesome. Thanks so much, Nate. So I'm going to go over a bit about my presentation, the lessons learned from Lahaina and LA. Could you go to the next slide, please, Kurt? All right, so as we discussed, all three of the fires we're discussing, the Lahaina fire, the Palisades fire, and the Eaton fire, were all textbook examples of built environment conflagrations, where destruction is not driven by the advancing wildfire front, but by uncontrolled fire spread between our structures. We know that conflagrations follow these three key factors: drought conditions, high wind events, and humans. In Lahaina, we saw that seasonal drought conditions, strong downsloping winds, intensified by an offshore hurricane, and several people-related factors, including invasive grasses from unmaintained fallow farmlands and dense neighborhoods with connected fuels like vehicles and fences, and an ignition from damaged infrastructure led to the disaster that day. In LA County, we saw a similar pattern with severe drought conditions across LA County, a powerful Santa Ana wind event, and densely built communities and human-caused ignitions in both of those fires. Next slide, please, Kurt. So when we have the conditions and an ignition that leads to a potential conflagration scenario, like in both the Lahaina and LA County fires, where we had ignitions that originated in wildland fuels and then spread into nearby communities, we see that spread occur through two primary pathways, embers and connected fuels. So we know that embers are capable of traveling over 2 miles, and they really allow these fires to cross fuel breaks like roads, parks, waterways, and these features that would otherwise disrupt fast and uniform fire spread and help contain these disasters. So embers land and accumulate against structures, vegetation, and other fuels, and especially under dry conditions, they're capable of igniting spot fires that grow and rapidly spread and merge and can create very intense fires rapidly. Structures and connected fuels that are vulnerable to ember ignition resulted in ignitions during the fires we're discussing across the communities, and that as a two-pronged factor where it creates multiple fire fronts within a community, which makes firefighting incredibly difficult, and it also increases fire intensity. The other pathway I want to discuss is connective fuels. Connective fuels can provide a direct pathway, so a direct chain, for fires to move from wildland fuels like in Lahaina the grassland fuels we were discussing into our communities. Saw a couple of examples where grassland fuels abutted roads or other potential fire breaks that had vehicles or other connective fuels that allowed the fire to jump and move on to parcels and spread directly to our main structures. And this can occur multiple times as fires move from different wildland areas in and out of our communities. Every structure that ignition that occurred via these two pathways results in significant ember generation from our structural fuels, high heat fluxes to surrounding homes, and an opportunity for structure-to-structure fire spread to increase fire intensity and increase loss. Next slide, please, Kurt. So once we have fire inside a community, the ignition of structure shifts the fire from wildland fuels to structural and urban fuels. And in these cases, we see that wind-driven structure fire spread is influenced by structure density, connective fuels, and building materials. Could you please advance the slide, Kurt? And another time. And again. And one more time. Thank you very much. Structure density incorporates the separation distance between our structures, and this is especially important in the prevailing wind direction. Connective fuels are the fuels that exist between our structures, and especially important are the ones that exist within zone 0. Connective fuels can include things like vehicles, vegetation, fences, ADUs or sheds. And then finally, our building materials, which includes what our structures are made out of. A lot of those elements that Nate was just discussing, whether or not we have non-combustible exterior siding, double pane tempered windows, a Class A roof covering. Those are our final line of defense. So all three of these factors were observed to directly influence structure outcomes in Lahaina and LA County. But a key takeaway from both of those fires was that the predominant factor that decided the extent of loss in both these fires was structure density. We saw that very, very close structure separation distances resulted in rapid structure fire spread and large areas of loss. To protect our structures, we need to address these factors by reducing potential fire exposures and increasing our structure resilience. This can be achieved through removing or relocating fuels to reduce exposures, with particular emphasis on the fuels located within the first 5 feet of our structure, and increasing our structure's resilience through hardening the exterior to resist what exposure remains. I want to touch a bit more on that and the structure density piece. When we have our communities that exist with tight structure, spacing distances, a key component is of our defense should be to focus on preventing ignitions through the removal of connective fuels and preventing direct fire exposure from ignitions within that ember zone 0. So a great benchmark for both reducing fire exposure and hardening our structures is detailed in our Wildfire Prepared Home program, which I would definitely recommend having a look. And also a great reference for kind of working with code compliance and with all the different types of building codes and resources you need to access when dealing with wildfire. I would definitely recommend the WUI handbook for fire risk assessment and mitigation that was published by the SFPE Foundation. They recently released their second version, and it does a great job of including all relevant building code and standards and different test methods for each different building component. And I found that to be a useful resource. So thank you very much. Looking forward to discussing this more.
Thank you, Evan. I believe we have our slides out of sequence, so bear with me here while I get the correct slides for Cameron. So pardon me for this.
Great, thanks, Kurt. And apologies, everyone, for my tardiness coming out of a project interview and balancing priorities.
All right. Is everybody seeing, or if I could get a thumbs up if we're seeing slides with GlueMac in the lower right-hand corner?
Not
We
yet.
are not
No,
seeing
no,
that yet.
I'm not giving the right slides. Pardon me. Where'd I go here? I've lost my Zoom controls. Sorry about this.
There we
How
go.
about now?
Coming up. Yep.
Perfect.
There you go.
All right, Kurt, you good if I just jump right in?
Yeah, go ahead.
Awesome. Well, I got to follow some awesome presentations when it comes to protecting property, protecting structures. But I took a little bit of a different look, being a mechanical engineer dealing with HVAC systems and building performance. We shifted into how does the fires that could occur, whether it be through urban environments or wildland fire smoke, how does that impact us as humans from a health and safety standpoint? And what are the things that we can do to mitigate wildland fire smoke within the buildings itself? So where we started, we want to go to the next. Where we started was a focus on health and human wellness. There we go. And so we covered the impacts to respiratory systems, cardiovascular, neurodevelopmental, as well as cancer risks that are attributed to wildland fire smoke. This is articulated in detail in the new standard that came out at the end of last year, ASHRAE 44, that goes through each and every single one of those in more detail, like I said. But we also covered some of the business case aspects, whether it's the Building Performance Institute of Europe, as well as some additional studies that came out of the public health manuals for Harvard. And then we also looked at some of the funding mechanisms as to how do K-12 institutions in Oregon get funding, where average daily attendance is a primary driver of the funding for the academic institution. So whether it's funding for schools, funding, getting the most productivity out of our employees or our tenants within our buildings, there is very much a business case to this as well. Once we shifted from the health impacts, next slide. We started talking about how does the smoke get into the building. And so we had a lot of conversation, discussion on passive systems such as architecture, making sure that the envelope is really tight. We talked about direct access to the outdoors and using vestibules and trying to create as few direct access locations where the outdoor environment can come into the indoor environment. We also spent a lot of time talking about keeping the building positively pressurized and running potentially a tissue test just to see if your existing building is positively pressurized. And we also talked about the gasketing and leaking that can occur for older buildings. So that's it on the architecture side. And then also potential zoning of maybe cleaner air spaces within an existing building. And then we started diving into more of the HVAC aspects, such as the enhanced filtration, using MERV 13s, considering critical space environments such as hospital, where we would upgrade to potentially a MERV 15. We talked a little bit about dealing with some of the VOCs, the chemicals, the smells, and activated carbon filters. And then I also spent a little bit of time talking about portable filtration units that could be deployed on an as-needed basis. All of this, again, is articulated in ASHRAE 44. And their goal for particulate matter that's 2.5 microns is what they call ALRA, which is as low as reasonably achievable. And then when we actually started this too, I did a quick demo, Kurt, assuming that you have the next slide in here on the tools from the EPA. We spent a little bit of time on the EPA multi-year plot and how to work with this publicly available tool, as well as how to correlate that to specific air stations on airnow.gov. And I believe that we wrapped on a handful of takeaways, which we can pull up, Kurt, here at the end, which is, how does, like I said, wildfire smoke contribute to health hazard and economic impact? What are the air quality tools that are available? What are both the proactive and reactive strategies that you can deploy that are both passive and active, whether it's through an active system or through passive architecture and passive programming design? And then we covered a handful of items as it relates to existing buildings, because modifying existing buildings tends to be an extreme challenge, especially when it comes to trying to add better performing filters into an existing HVAC system. So that's what we covered during session 3. Kurt, back to you.
Great. Thank you, Cameron. Jake, bear with me while I switch back over and get our slides here. All right, are we seeing, Jake, are we seeing your slides?
That's it.
Awesome.
All right. I'm going to go quick so that we can get to question and answers. I'll just do a brief recap of what my presentation was. It was, resiliency with commercial and multifamily buildings. And we looked at the intersection of wildfire behavior, building science, and kind of code adoption, and how each contributes to the overall community resilience. And we went over Lahaina and the Los Angeles fires, the Palisades and Eaton fires, and how they actually what actually caused them to burn. Next slide, please.
Oh, I see what happened here. My bad.
That's
So
okay.
how's that?
We'll go back one more.
I think we have things out of order. Here, Jake.
Okay, I think you're going forward.
Yeah, let me get your, something this got put together wrong here. Oh, apologize everybody for this.
While we're waiting, I just had a question, Evan. I heard each house that burns could produce well over 6 million substantial embers. I'm just wondering if that's in the neighborhood or am I low?
I think that Faraz is the right person to ask. I'm sorry, I'm not I don't know that off the top of my head, but that feels like correct ballpark. And it's not only the little ones too, you get
The big ones. The big ones.
fist-size embers rolling around. Yeah.
All right, so we want to put this in present mode and we're good.
Yep, that's the right slide. That's the first one.
My apologies here.
Perfect.
Okay, now you're perfect.
I think that's an overstatement, but I'll keep going.
So again, we went over the Lahaina and all the Palisades and Eaton fires, and what they did was they really reinforced the topography and wind alignment and how that can multiply fire spread rates. And true resilience starts long before ignition, and it starts with planning of materials and your defensible layout. Next slide, please. So again, you're going to hear this numerous times, but embers are key here. 90% of all structural losses in the wildfires come from ember exposure, not really direct flame contact. The most effective strategy is to think of every opening as a potential ember entry point. We discussed a number of several key defenses using 8-inch ember resistant vents, sealing all penetrations, and using non-combustible cladding, like fiber cement or stucco, and protecting open with tempered glass and fire rated doors. Also, along with the temper rated glass, we want to use, instead of wood, maybe use metal or aluminum, which is the best. Next slide, please. Go back. There you go. Next, we looked at the defensible space design. The areas around the building. You've heard this already today. To increase your survival odds. We call it zone 0. The first 5 feet, which is the most critical, should be, in essence, completely non-combustible. No plants, mulch, or furniture. There are some plants. Kurt, I emailed you a PDF. If you could put that in the chat. I was asked that question the last time where I got my plant recommendations, and I put a link in the chat for you, a PDF in the chat. It's actually Colorado State is who I used. So he'll put that in the chat later, but you can look at those type of plants and it gives you all the information you could want about defensible plants. Multifamily buildings, we discussed how balconies and decks can act as ember traps. Metal or concrete construction is obviously the best, in an enclosed drainage system, really makes a huge difference. Ultimately, defensible space isn't just landscaping. It's kind of the performance zone that determines, whether a building ignites and survives. And Nate's slides that he showed with the architect that built that house shows exactly that. The way he built it was designed not to ignite, and it's exactly what happened. Next slide, please. Finally, the policy and economic side of this. Codes like the International Law and Urban Interface, the IWUI, California's 7A, and NFPA 1144 really give clear standards for ignition-resistant construction, access, and defensible space. Oregon's legislation, like SB 762 and SB 80, show how policy can drive statewide resilience, even if implementation challenges exist. And again, you guys are the ones that are going to be putting forth these design implementations, and it's really on you guys to live even higher than the code. Financially, we talked about this in my presentation. 2 to 4% construction premium for fire-resistant design, but that investment delivers 15 to 20% in annual insurance savings and up to 75% in loss reduction. And that's a 3-to-1 return on investment, and that's a great return on your investment. I think the insurance savings alone is enough personally, but to save a 3-to-1 on your investment is outstanding. And that's just another way to kind of pitch it to who you're designing for. It's not, resilience isn't just smart safety policy, it's smart business. And that's it for me. It was a quick wrap up, and this way we can move into the Q&A.
Great, go ahead, Jake. Thank you.
Okay. Let me get to that real quick. All right, Nate. These are your quick questions for you. Where are the biggest gaps in today's wildfire resilience approach?
I guess I think all of us looking at the losses would say that we still design for basically wildland to building, but the reality now more and more is that it's we see that embers and structure to structure spread dominate at these dense edges, but many of the rules that we're dealing with really still assume a single wildland front, which is something that we just saw isn't the case in many of these communities that are burning. We also have to really think about life cycle. What's the maintenance like for that 0 to 5 foot? How are we dealing with our gutters, our vents, all of that? It's under specified and often under budgeted. And then finally, I think that the WUI rules that we're dealing with do tend to skew to single family.
They do.
We have multifamily commercial vulnerabilities. We have large roofs, we have vented rain screens, et cetera, and those will need explicit treatment as well.
Great. Are current policies codes enough, or should we advocate new measures?
I think we should tighten 3 levers in parallel. So land use, details, and operations. So when I think of land use and adjacency, that's about breaking that combustible connectivity. That's the fences, the sheds, the attachments, et cetera. The details at higher density, what I mean by that is that we really have to treat fences, eaves, vents, and rain screens as the ignition pathways. And we have to interrupt those. And then on operations, I believe we need this annual zone zero, as I call it, the 0 to 5 foot. We need verification on that, because if we don't verify it, it becomes the thing that leads to the fire spread down the road, that causes the community to ignite. It's interesting, you know, all it takes is one house in a series of houses to ignite the community around it. You know, traditionally under low wind conditions, you know, something like what didn't happen in 2020 in Oregon, in multiple locations, when you have that, it's not as big of a deal. But when one structure goes up during high wind conditions, it's disproportionate, the number of embers that generates, and you can't address all of those fires very often simultaneously.
Great. In your opinion, what should architects prioritize on projects right now?
I keep it simple. 0 to 5 foot. Think about creative landscaping. Everyone is concerned about landscaping. What does this mean for the palette? But landscaping is one of the most effective places you can sort of put your design sense and your money. Then just focus on the structure, that envelope. Think about using a listed vent. If you know, I think of the difference between a listed vent and just a standard vent. Many of the listed vents have intumescent in the vent, so that if you have a structure burning next to you, that intumescent will close up, because simply having a screen against embers isn't always enough. We also have to think about neighborhood scale spacing breaks, you know, using courts, alleys, hardscape bands. You know, this could even be on a single property, but we want to use that as part of our design. Anything we can use will help dramatically, and you just have to make it so that the firefighters have a chance to address these fires.
Great. How can we make resilience easy to maintain over time?
Design for maintenance. You know, think about what it will be in the future. So again, don't tempt yourself with things in zone zero that are difficult, you know, that may look good today, but in 3 years after some good rain, they'll become a hazard to the structure. There's a lot of low touch components that we can think about, like metal gutters with debris screens. And then there's things like operations and maintenance triggers, you know, like maybe we can implement post red flag inspections or digital logs that are tied to the warranty or an HOA. And again, this is for the benefit of the community, but that's what I think we need to start thinking about differently.
Great. And last one, have recent fires shown improvements from past lessons?
You know, last Sunday I drove through the Palisades, and there were certain houses that had just popped up exactly the way they were before. And there were others that were clearly taking a different approach as we begin the rebuild. So I'm getting mixed signals. But I think overall, the improvements, you know, there's a conversation that all of us are having, including right here and now. And this hasn't happened like this in the past that I can recall. So I'm looking at that as a very positive thing, and it's a lesson learned almost. Like let's first start to talk about it and put a bunch of smart minds to work, make people aware, and then, you know, I think at the end of the day, we can start to address these challenges that we keep talking about.
Great, thanks. I'm gonna give it over to you and you can take it from here.
Okay, thank you. So we'll move on to this topic of lessons from recent wildfires. And we've had a couple of recent events that shaped today's conversation that we've talked about. We met, you know, we spoke about Lahaina and Los Angeles, and across both, we had different conditions that were aligning. We had significant wind-driven embers that really outran what the fire department could deal with. We lost water, you know, which is a very common thing. Everywhere we had these structures that acted like fuel ladders, the same way we think of vegetation. So we have a network problem, connectivity and proximity, which is something that we can and should address. This brings me to my questions. And I think, first of all, Evan, I want to ask you, what common factors drove the devastation in Lahaina and Los Angeles in here that in recently in 2025?
Yeah, absolutely. And I think we could start, it's those three main factors. It's that structure separation, building materials, and connective fuels. And they all kind of work together and play. And the proximity and connectivity statement you used, I really like there. But I guess I can give some examples. We heard Jake say that statement that 90% of all structure loss comes from ember ignitions. And part of that is, our building materials. It's that we don't have proper protection for our openings. During our post-disaster investigation, it was rare that we found a vent that even had 1/8-inch mesh screening or less, let alone a rated vent. So that is like one, that's our building material portion. It's very low-hanging fruit, in my opinion, on what we can do to make a difference. But part of that 90% of ignitions from embers includes those ember ignitions at the base of our structures and ember ignitions that occur close enough to the home to cause direct flame contact. And that's a couple things. It's those connective fuels, providing, basically a place for embers to be sheltered and taken in right next to our structures. And then those ignitions provide some of the most intense exposures that come with direct flame contact. And I can tell you that our building materials aren't designed to withstand those types of exposures. Even our exterior walls, I'm working on a project right now because all of our building code requirements test the open face of our wall system. That detail, that foundation to wall detail, is not tested in any way, shape, or form, right? And we can ignite a non-combustible exterior wall covering with a mulch fire at the base of the wall. We're running experiments right now on this, just because of how that detail can occur.
Yeah.
So we're encountering these really difficult problems, especially when we have those vulnerabilities close to our structure. Structure separation, again, it's really difficult in our densely built communities. This is a factor we're trying to carry into all of our new developments, but as we retrofit, we're looking to prevent ignitions, right? We're looking to prevent ignitions. That 10-foot separation distance is really a problem only if one of the structures has ignited. And again, there's a lot of opportunities where if we can take advantage of our roadways or even our non-combustible alleyways or things that you were discussing earlier, if we can take advantage of those through the prevention of ignition of our structures, we can make this a block-to-block problem rather than a community-wide loss problem.
Yeah. And so which design features failed versus helped, in your opinion?
Absolutely. So one thing that I think we've talked about a lot on previous fires and didn't see as much here that is kind of an instance that it was helping was our roofs. So due to our code changes and the use of Class A roofs, we saw a lot of success. We're not seeing roof ignitions as one of our key mechanisms of failure and a big key driver of loss by generation of embers. Previously, we had seen that combustible roof coverings would likely ignite and then take 10 houses downwind with them. Design features that failed it was really going back to vents. We saw multiple instances of structures that had ignited internally. And when we see that a few times, there's a lot of those instances that we're not going to be able to document because those structures will be total losses. And then at that point, it's impossible to tell what happened. But the fact that we did see multiple instances of that occurrence, and in order to prevent that from being a total loss, firefighters are entering that structure and extinguishing it. just goes to show that that's likely something that contributed very, very significantly.
Yeah.
Another helper was resilient exterior walls, predominantly non-combustible wall coverings, but just our connective fuels and direct flame contact to structures cost us from really being able to take advantage of that to the full extent.
Yeah. So if it was your house, what two changes would you recommend immediately to everyone here?
I think, immediately, this is my same recommendation to homeowners as well, as immediately it's zone 0 and at least getting 1/8 inch or finer mesh on all your vents. These are things that are achievable, generally very, very low cost, and make the biggest difference. You're addressing that 90% of all initial ignitions.
Yeah.
And that's benefiting your structure and your neighbors. And we can work up from there.
All right. Thank you very much. Cameron, I'm really fascinated by this idea of the air quality and how it relates to wildfire. It seems to me that the bigger killer, the bigger health problem, for most people actually arises from the post-fire effects. When you look at the numbers, I'm curious, what works best to keep smoke out and indoor air healthy in new buildings that people are designing?
So new buildings, it's really 3 or 4 key things, one of which is absolutely needs to focus on filtration, appropriate filtration. Buildings require ventilation, which means we're pulling outside air into these buildings. And because of that intentional process, having good filters on that outside air is mission critical.
Yeah.
The second of which would be focusing on trying to have a really tight envelope, especially as it relates to Oregon. The new energy code is going to require a lot more detailing on thermal bridging and documentation with check. And so just making sure that you're detailing out all of those potential openings on the envelope is also a great opportunity to do a good job. The third thing would be, of course, the vestibules, making sure that we're limiting direct access connections from the outdoors to the indoors, especially with high traffic areas. So if you have large groups of people that are rushing into an office building in the morning, or classes getting out and doors are being held open, that creates this opportunity for the air to come in. But you can mitigate that with the fourth item, which is making sure that we're designing buildings to be positively pressurized. So the days of pulling, using a trickle vent and pulling a multifamily apartment building to negative pressure with the exhaust fan in the bathroom and intentionally trying to pull out unfiltered outside air, that's an example of pulling a building to negative pressure, when best practice would be to design a system with outside air that's filtered and creating positive pressure for the building, so that when you do have the doors open or the windows open, or if you have any sort of leaky gaskets in your envelope, the air is pushing from the building to the outside instead of pulling the wildfire smoke into the building.
Got it. And how would how does this apply to older buildings? Anything different, or how would you?
It's a similar process. I think that the things that we can control would be evaluating the envelope and probably taking a look at commissioning, both commissioning the systems to make sure that we're trying to control the building to positive pressure. That is something that would apply very much to existing buildings, but also commissioning the envelope, see how leaky the envelope is. Should we invest in actually improving the envelope as a part of our existing building? And then the last one, which I already mentioned this already, and ASHRAE 44 and other ASHRAE documents have guidance on concerns of adding additional filtration, but adding additional filtration is absolutely a great step for existing buildings. What I will say on top of that, though, Nate, is that having a wildfire smoke readiness program and coming up with policy for your existing building of what are the actions that your maintenance team is going to do, what are the action items that your team is going to deploy in order to mitigate smoke in your existing building, understanding your unique context.
Yeah.
So policy becomes a big part of it too.
I do have one follow-up on that. Have any of your clients approached you about during fire positive pressure, meaning like to minimize smoke damage during a fire event?
Yes. So short answer is yes. So guidance is to turn off your airside economizers. And some clients are going so far as to closing their outside air dampers, Nate. So they're really intentionally trying to not pull outside air into the building. On some work that I was sharing with Kurt and some other folks that I do with LAUSD, they have a quote unquote shelter in place mode. And that's for any sort of chemical offenders or any sort of hooligans that might, try and drop a stink bomb right, next to an air handling unit with outside air, right? So that shelter in place mode achieves the same effect. We're trying to create positive pressure inside the building and limit the amount of outside air coming in.
Yeah, that's
And
great. Go ahead.
And I would just say that all that guidance is also articulated in ASHRAE, and all the work that we put together with the EPA also speaks to these sorts of things.
Yeah, sounds like an amazing document. Yeah, so much damage seems to be coming from the smoke, right? If you survive, if you're lucky enough to survive the fire, that's the next step. Thank you very much. I'm gonna move on to Jake, and Jake, I want to first say that one of the things I most appreciate about FEMA is that FEMA has always approached this as a multi-hazard phenomena, the big ones, right? Wildfire, wind,
Mhm.
flood, hail, all of that. And I think you have like 12 others, in there.
Right. Yeah. Yeah.
And what everyone on, who's online right now should appreciate, we were actually just talking about it, talking about how many of these events are not isolated. One leads to the other. But I just wanted to put a shout out there because I think that's one thing that the FEMA guidance offers that's unique in many respects. My first question for you, Jake, is which commercial and multifamily features do you think need rethinking in fire-prone areas?
uh, I think it comes down to about 4 or 5 things. Um, and I'll just start with the easiest low hanging fruit first, and that's the zone 0 to 5 foot zone. Um, that's one of the easiest ways to help uh, make your multifamily or commercial building, a little more resilient is by adhering to that 0 to 5 foot zone, and have more of a hardscape, um, and non-combustible breaks in there. Um, if you have fences too close, or trees too close to the building, they create just that continual fuel path. So I think that's the easiest and first place to start. There's a couple other ways, depending on if you're retrofitting or you're building brand new. But for the second area I would look at is, again, like we just talked about, are the eaves and soffits, open eaves and soffits that collect the embers. Um, I'll pop one more thing onto that too as well, is large roof overhangs. Overhangs trap gas and heat, and that collects embers, and then it just works as a like a stove, and it just continues to heat and heat. Um, open eaves and soffits, perforated panels, and are basically direct ember entry points to attics. So just using those small things, like less than a 16th inch, non-combustible mesh, utilizing those, they're very cost effective, and they can really make the building a lot more resilient just by stopping ember intrusion.
Yeah.
Another thing that we've been looking at too as well is and I find that as a fire marshal, I found this on numerous occasions. The shared attic spaces in the multifamilies and commercial buildings, they are notorious for contractors, cable companies, electricians, HVAC, cutting holes so that they can walk in between each attic, and that is just an open pathway for fire. Smoke and fire both will just roll through there like it's nothing will stop it. So, I think one of the ways to do that is compartmentalize attics, with rated draft stops and extend unit, unit walls to the deck, and avoid soffit overhangs, um, and use the listed ember resistant vents where they're needed. Um, and that's going to be a maintenance issue too. When I do find those, I make sure that I mention or sit down with the facility maintenance or the owner of the multifamily and explain to them how they can fix this. The fire rated walls they need to repair, and how they go about doing that, because it's imperative for the building. Once those attics start going, the roof is gone, and then that's it.
Yeah.
So, another way, when we're on the topic of attics and roofs, another way is to, and you showed it in your example of the architect's house. Stay away from the complex roof valleys and parapet wall interfaces, because those collect a lot of debris, and those embers, even if you have a Class A roof, those embers are going to find that debris and get it going. So, along with the Class A roof, try to stay away from, the roofs and the valleys, and try to stay more of a flat roof like he had. And again, we'll talk about rain screens and cladding. Unprotected cavities, they just act like flues. They pull the embers upward, and they accelerate the flame spread. So, where rain screens are needed, for moisture control, cap the top and bottom and open the joints with non-combustible mesh. We've talked about the mesh already, less than a 16th inch. And, on the facades, stay with non-combustible, and ignition resistant facades, so that you're fighting that heat and embers and direct fire contact. And I think those are really the easiest ways to start rethinking in fire prone areas, and that comes into play when you start looking at where you're building and site evaluation.
Does that approach vary for larger buildings, or is it pretty much you're thinking about the same things?
Yeah, well, for larger buildings, you're going to want to think the same things. You're not going to really, in a larger commercial building, you're probably not going to have those attic spaces that are intruded on. But you're going to want to maintain those zones, those hazard resistant zones, your vents, and your Class A roof are all going to come into play there.
So my last question to you is, in three, what would be your top, maybe 3 to 5, whatever, what would be your top retrofit wins, and how would you stage them?
So retrofitting is again, it can be very cost effective, and it help your insurance. I would say, the 0 to 5, number one, non-combustible zone, more bang for your buck. Replace your mulch and your plantings with hardscape, combustible attachments. Make sure they're non-combustible, and that's going to be your biggest bang for your buck on a retrofit. It's something that you can easily and quickly accomplish. Second is openings. Your window openings, upgrade to your dual pane and tempered exterior. Add your ember screens to your skylights. Weather strip your doors to reduce ember intrusion. Those are easier. The windows aren't very cost effective, but when you're talking about insurance, that's a upgrade that is going to pay off dividends. Roof edges, of course, you're going to want to reclass to a Class A roof, and ridges and soffits. You're going to want to, convert those. Metal edge flashings. Flashing isn't all that expensive either. Those are just a couple easy ways for retrofits that'll work great, and you'll really get a lot of bang for your buck.
Yeah, thank you. So I think I'm just gonna, what I think I'll do in the interest of time, I see we're at the hour. I just want to put out a question, the two questions for the group to whoever wants to answer it. The first would be, how do architects, how do we make this business case to clients today? What is the business case for doing this for someone who's designing these homes? If anyone wants to take a shot at that. And I think, Jake, I know you had some great statistics
Yeah.
of, return on.
Yeah. In my opinion, the way I would pitch it and the way I do for my Region 4, building codes is, highlight the return on investment. You're looking at a 3-to-1 return on investment, and anyone that's building or a commercial builder, this is an investment, and that's what they are thinking about. They are thinking about those numbers. Also, if you are building or going to build or retrofit build in a wildland fire urban area, you're just going to want to make sure that they understand that they're going to gain by going more resilient and using these wildland codes. They're going to 15 to 20% in annual insurance savings.
Yeah.
That's going to be a big sell as well, because they're going to know what the insurance costs are. They're going to realize that. And
Plus
Go ahead.
we're hearing that people are increasing their coverage limits if you do certain things, which is that could be a bigger gain in some cases.
Exactly. And I was just getting ready to say that they're doing the cost evaluations, and they're including the insurance. And when you do these and then you go through the insurance companies and you show all your resilient wildland fire upgrades, you're gonna have an even bigger savings. So I think those are two important ways that I would utilize it in my talking to builders or whoever you're designing for, and really take part in the process of site design and looking for sites. That will all come into play. And again, like I told you about the topography, try to look at areas that aren't so wind tunnel coming down the slope, at the end of a blowtorch, and if they are, then maybe look at a different site design or see how you can design it that makes it a little less right in the line of fire.
Yeah.
And those are, like I told you guys, I love working with architects, and these are just simple ways that you can utilize in your toolbox to talk to the people you're designing for. And some people may not even realize it, the cost savings that they can get. It's just another way to help.
And it's always nice to not have your home that you're spending all this money on designing a legacy home, whatever, have it burned down. So I'm going to close with one last question for the group. Whoever wants to take it on, how do we navigate the density versus resilience tension? If anyone wants to take a shot at that. And I'll expand. I'll just say, on the one hand, we're trying to build these communities efficiently, inexpensively. We have sometimes bigger communities, but sometimes individual houses in a community that are built one at a time, but they're close together. And yet we recognize, through what Evan was talking about, this is potentially a problem. So what's our way forward? If anyone wants to take a stab at that.
I'll let Evan and Jake speak to that. So.
Sorry, Cameron. I was going to say, I just have a couple points there. I think one key design factor will be, as we transition from individual design for wildfire resilience to community level design for wildfire resilience, we can start to change our perspective on, the assumption isn't always that the neighbor's house has already been ignited and we're designing for that level of exposure. We start to be able to design for the community as a whole being resilient to wildfire rather than parcel by parcel. And I think as we start to develop that framework and that mindset, that will really allow us for increased density in things. I think we have a ways to go before we get there. but then also transitioning and creating, and I know we're working on, we'll soon release recommendations on the multifamily structures as well. So making sure that, you know, we are incorporating these multifamily structures and making them resilient as possible.
Thank you. All right, well, I think we're at the end of our time. Thank you everyone for joining us today, and I'll turn it back over to Kurt. Go from there.
Great. Well, thank you very much, Nate, and thank you to Jake, Evan, and Cameron for all your time in this series. I just want to remind everybody that the recording will be available next week. There are some handouts that Jake sent out. There's a link to the plant list in the chat. I think we'll also try and get that sent out after the meeting. There's also a link to the website I had mentioned related to the AIA statement on the White House as well. It's in the chat. So thank you, everybody. This concludes the fire resiliency series, and it's been nice to see everybody's participation. Alan, Jay, Charles, Logan, and I, and anyone else who's interested would like to try and do it again next year. If you are at all interested, please reach out to me. If you don't have my email address, you can reach out through the AIA Oregon staff to get to this, and we'll do some planning for this next year. So thank you, everybody. Have a great rest of your day and enjoy the weekend.
Thank you.
Thank you. Thanks, everybody.
Appreciate it.
Awesome.
Thank you, everyone.
All right. Thank you very much, Jake. I apologize about the PowerPoint.
No worries.
Slides got in the wrong spot as everything got combined this morning, and I didn't realize it.
Okay.
I'm looking to oh shit. So anyway,
No worries, no worries. I just
All
wanted
right.
to say thank you guys, and Alan, you're here.